Try out how to do these type of questions. So here we have been given a rod of length L and Q, and we have placed a charge Q, small q, in front of this rod, and it's placed at a distance of small a in front of this rod. Now the total distance of it is L plus a, right? And now let's start with this question solution. So we all know the formula is F K Q1 Q2 upon R square, K Q1 Q2 upon R square. This is the formula, right? Now obviously we know that K Q, this small q. Now this whole, as we all know that this formula is applicable only for point charges, right? So we can't apply this for such a big rod. So we have to basically take a small piece of this rod. Let me take this small piece, and let me assume that this is having a length of dx, right? Let me just make it quite bigger. So I took out this small piece, right, and is having dx length, and obviously the charge is also then smaller dq. Okay, understood? Right, now let's see. So if I have to write the charge value of dq, that's the small part, so it's going to be so as we all know, the formula is lambda dr. We all know this formula, I hope, right? So here dq will be equals to, as we all know that lambda is going to be equal at every single point, it's going to be constant, and lambda is q by l. As I've said, q equals to lambda l, or q equals to lambda dr, right? It's length or dr, same thing. So lambda can be written as q by l, right? So let me write here q by l, right, into dr. So let me write it as it is. Now putting this value in this, so I'll get what? Fk small q into this dq, right? I have to put the value of dq here, and this is q. So dq value we've got q upon l into dr. Fine? Getting everyone? Right. One thing we haven't substituted, that we have took x in place of r. So let me substitute it over here, right? Now what we can see from here, k q1 q2 upon r square also we have, right? So r square is x square. You get it? Is how x came, right? Because we have took this distance x into dx. Is it clear to everyone how we did it? So basically I've cut it down. Okay, so let me write it down because it's quite messy. Kq upon x square q upon l dx. This is what basically at the end I've got. Now let's solve it further. Now basically from this point, from a to this, I have to find. So basically from like a to a plus l, I have to find it. Let me just write it out. F equals to from a to a plus l, because it's from a this distance to this whole distance we have to basically find it, right? So from a to a plus l, so it's going to be k, q is constant, upon x square. Is x square constant? No, x square is not constant. Why it's not constant? Obviously because the charge is imposing over here, so this is not constant, but L length is definitely constant, right? We know L length is what? This whole length of rod. This is constant. Then we have what? We have Q, and Q is also constant. Then we have dx upon x square, and this will be here a plus n. Okay, got it everyone? Now let's solve it further. So it will give us k q upon l, and now a say a plus l. Now we can write x square, 1 upon x square, as x minus 2 into dx, right? Now dx, now let's just integrate it. So k q upon l a plus l, this will be x ki power. So we know that we have to basically add +1 here, so it will be x minus 1 upon whatever is the power, add +1 again in it, so here also will be power -1. Now we have differentiated, right? So I can write it like this. Can I? Right? This negative sign will be here, transferred here, so it will be minus kq q upon l a plus l. So to simplify it, I am writing it again as 1 upon x. So it will be minus q upon l. Now let's just put in the values. Be careful while putting the values. So it is going to be 1 upon a plus l minus 1 upon a. Minus q upon l. We will take the LCM. So a will be here, a plus l. This will be cancelled out. So it's going to give us minus q upon l, l upon a. So L say L will be cancelled out. Okay, so we're getting this kq upon AL into A. Okay, now one thing that you might be confused a bit is where this went. So basically the negative charge will be from here. So it is going to be like this, A minus A plus L. So here we will have minus. So this minus will be positive.